Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Geometrical, cis-trans, isomerism in cycloalkanes arises when substituents on the ring can be placed either on the same face, cis, or opposite faces, trans, of the ring plane. The compound shown is 1,3,5-trimethylcyclohexane, which has 3 methyl groups at positions 1, 3, and 5 of the cyclohexane ring. Moving on to the next step. Identify the stereocenters. Each of C1, C3 and C5 bears one methyl group and is a stereocenter. Each has 2 different substituents relative to the ring plane, up or down. Moving on to the next step. Count possible arrangements. With 3 stereocenters, there are in principle 3 is equal to 8 arrangements, but many are equivalent by symmetry. And for the final step, all 3 methyls on the same face, all cis, 1, 3, 5, all cis. This molecule has a C3V symmetry axis and is achiral. It has a plane of symmetry. This is one isomer. 2 methyls on one face, 1 on the other face. By the symmetry of the 1, 3, 5 positions, all arrangements of 2 up, 1 down are equivalent to each other. Any one of the 3 can be down, but due to the 3-fold symmetry they all give the same compound. This is a second isomer. Wait, let us reconsider. With positions 1, 3, 5 being equivalent by the C3 axis, we have A. All 3 up, all cis 1 compound. B. 2 up, 1 down. All such arrangements are related by the C3 rotation, so this is 1 compound, but we need to check if 1 up, 2 down is the same as 2 up, 1 down by a ring flip or reflection. In a flat representation, geometric isomerism, not conformational, 2 up, 1 down and 1 up, 2 down are mirror images. If they are non-superimposable, they are enantiomers and count as separate geometric isomers. All cis, all 3 methyls same side has a C3 axis and 3 mirror planes, it is achiral. 1 isomer. 2 up, 1 down, this isomer lacks a plane of symmetry and is chiral. Its mirror image is 1 up, 2 down. These 2 are enantiomers. Since geometric isomerism counts cis-trans arrangements, including enantiomeric pairs as distinct geometric isomers when they differ in spatial arrangement, these count as 2 separate geometric isomers. Total geometric isomers is equal to 1, all cis, achiral, plus 2, the chiral pair, 2 up 1 down and 1 up 2 down, is equal to 3 geometric isomers. Why other options fail? A. 0, incorrect, there are clearly different spatial arrangements possible. B. 2, incorrect, this would miss counting the enantiomeric chiral pair as 2 separate isomers. D. 4, incorrect, overcounts because the 3-fold symmetry reduces the number of distinct arrangements. Therefore, the correct answer is C. Therefore, the correct answer is option C.